we're going to go over the volume and surface area of a triangular prism. I've drawn a triangular prism here, not to scale of course, and I've got several dimensions on here. I've got a length of my prism, and I've also got a base and a height with which we are going to calculate the volume. The way you calculate the volume of a triangular prism, so volume equals the base times the height times the length of the prism, all divided by 2. You can also look at that as the area of the triangle at the front multiplied by the length. Okay, so base times height divided by 2 would be the area of the triangle at the front, and then you multiply it by how long the prism is. These two expressions are equivalent. So I'm going to indicate what my base, height, and length are. Base equals 5 centimeters, and that is because it is perpendicular or 90 degrees to my height. My height, therefore, is 4 centimeters, and the length of my prism is 6 centimeters. I'll zoom out here a little bit so you can see this. Okay, so the length equals 6 centimeters. To calculate the volume, I'm going to multiply these three values together, base times height times length, and I'm going to divide by 2, so that equals 5 centimeters times 4 centimeters times 6 centimeters, and I'm going to divide whatever I get there by 2. 5 fours are 20, 20 times 6 is 120, so I get 120 centimeters cubed divided by 2, which equals 60 cubic centimeters. And that's how you calculate the volume of that triangular prism. So just to recap, you multiply base times height times length, and you divide that by 2. And the other way of looking at it, as I mentioned, was find the area of the triangle and then multiply it by however long it is. So the way you find the area of a triangle is base times height divided by 2, and then you multiply it by how long that prism is. I will go on to surface area in just a moment. Okay, so now we're going to go over surface area. The difficult thing with surface area of a triangular prism is that it's really difficult to visualize because we have two hidden sides. But the way you can think of a triangular prism is that it's made up of 2 triangles, which are congruent, and 3 rectangles. The triangles are congruent, as I mentioned, so they're going to have the same area as each other. What we'll do is we'll multiply our base times our height of our triangle. The area of a triangle equals base times height divided by 2. And in this case, our base is 5 and our height is 4 centimeters. So 5 centimeters times 4 centimeters divided by 2, and that equals 20 centimeters divided by 2, sorry, 20 square centimeters divided by 2, so 10 square centimeters. So each of those triangles is going to be 10 centimeters squared. Then we've got 3 rectangles, and those rectangles make up each side of the triangular prism. So the way you can think about it is we've got a rectangle right here, which we can see, but we've also got one on the side, and we've also got one on the bottom, and we can't see those the way it's drawn on this two-dimensional page, but you can imagine that there are 3 rectangles that are connecting those triangles at either end. Let's take a look at this rectangle right here. We have a width of 4.5 centimeters and a length of 6. So 6 times 4.5, the decimal might give me some trouble here, but that would be 27 centimeters squared. So the area of rectangle 1, I'm just putting this so I can keep my figure straight, is length times width. That equals 4.5 centimeters times 6 centimeters, and that would equal 27 square centimeters. Our second rectangle, sorry, on the left side of this prism, I'm going to call rectangle 2. And we calculate the area of a rectangle again, length times width. In this case, the width is going to be this length right here. So the width is going to be this dimension. So it's going to be made up by one of the sides of the triangle, much like this one, and the bottom one will be. And the length is going to stay the same. The length is still going to be 6. So this rectangle is going to be on the left-hand side. It's going to be a 5 by 6 rectangle. So we're going to go 5 centimeters by 6 centimeters, and that's 30 square centimeters. Finally, we've got our bottom rectangle. In this case, this length is the same as this length, so it's also going to be a 5 by 6 rectangle, which would make this triangle on the front an isosceles triangle because two of the sides are the same length. So we've got 5 centimeters by 6 centimeters, and that equals 30 square centimeters. Now, just like surface area of a rectangular prism, you add up all the areas of all the faces. Please note that this area right here is only one of the two triangles. So we have to have triangle 2. So the area of triangle 2 equals the area of triangle 1. So that equals 10 square centimeters too. Okay, so then all I have to do to get the surface area is add up the areas of each face. So 10 plus 10 is 20, plus 30 is 50, plus 30 is 80, plus 27 means that the surface area is 107 centimeters squared. Hopefully that's clear. If not, go back and try again, have another look at it. Essentially, all you have to do is visualize this prism as 3 rectangles and 2 triangles. Get the area of both triangles. The triangles are congruent, so they're going to have the same area, which is what we have here and here. The rectangles are made up by the length of the prism and each side of the triangles. Hopefully that's clear. Have a great evening or day or whatever it may be while you're watching this, and thanks for tuning in. Bye-bye.